Today we're going to revisit the idea of a scatter plot. And I know that if you remember all the way back to grade 9 and all the fun days preparing for your EQAO test, you did some scatter plots and you looked at how to construct those. So I know that everybody will remember that. In the statistics course that we're studying right now, a scatter plot is a really useful thing. It's actually a lot more useful than just being able to plot a graph from an equation, like a linear graph. We know in the real world that some things are kind of linear, but not necessarily perfectly linear, and that really doesn't take away from the fact that there is a linear relationship. But in the real world, there are always other factors that are going to affect some of the values and the data values that you get. And so we wouldn't really expect every single point to line up exactly on a straight line on a graph in the real world. And that's really all a scatter plot is. It's when you put a whole bunch of dots on a graph, if you can see a trend, so that you can see a place where you could kind of draw a straight line, and all of the points on the graph would sort of be an equal distance from the line, either above or below, then you really do have a linear trend in that data or a linear relationship. And that's really more important than some of the examples you've done in the past where everything lines up on the same straight line. So let's have a look at a couple of examples. Sorry. In example 1, they're going to give us a chart, and it says that the following data shows the percentage of women in the Canadian workforce, and they need a fully labeled scatter plot. And so the data that's provided looks like it goes up every 5 years. And so in terms of our graph, we should already be thinking about dependent and independent variables. Time is always an independent variable because nothing really affects time. It's going to go forward whether we like it or not. Percentage of women is going to be our dependent variable because if I said what was the percentage of women in the workforce, you would have to say, well, it depends. Which year are you talking about? And so if you can ask yourself that question, it makes it a lot easier to determine the independent and dependent variables. So when we create our scatter plot, let's just cheat a little bit, and we're going to bring up the answer here. And as you can see, they've already created a graph and a scatter plot. And really, it looks like somebody was trying to draw a straight line but kind of went off course a little bit. But we can see that straight line pattern through the points. And so if we can see that straight line pattern, it tells us that there is a relationship, and that relationship is a positive one because as one of our variables increases, the other variable also increases. And we can see that this relationship is quite strong because all of the points are very, very close to the line. There's only one point down here, this guy here, that is a little bit off the line. And the rest of them are much, much closer to the line. And so we would refer to this guy as an outlier. An outlier is something that's just too far away or a little bit more than normal away from the rest of the data. In the second question for our example, it asks us to describe the relationship between the year and the percentage of women in the Canadian workforce. So we're using the same data from the chart above, and let's have a look at their line of best fit. And so their line is a lot easier to read than my line, but we can see that what they've done is they've created a line that goes through a couple of the points, but really most of the points are not on the line. The other thing that you notice is that there's just about an equal number of points above the line as there is below the line, and that the line is sort of the same distance away from most of the points. So that's what we're trying to achieve when we draw a line of best fit. Again, we've got our outlier at the bottom here, this guy here, who is a little bit more than the average bear away from our line of best fit. So that might be a piece of data that we need to throw out, and we'll look at how to determine whether or not we should throw out an outlier a little bit later on in the course. So going back to the question that they asked us in example 2 about the relationship, we talked a little bit already about that relationship. We talked about it being positive, and we said it was a pretty strong relationship because most points were very, very close to the line. And so they're elaborating here for us the line of best fit. The line of best fit shows that the two variables are related and that we have a positive relationship because one is going up as the other one is increasing, and that it's a strong relationship because both of those, or all of the points, are very close to the line that we drew. And here they also mention the fact that as the year increases, so does the percentage, which we already said, but there is an exception to that rule in the year 1960, which we have talked about already as an outlier. So try the practice questions that are included in the lesson, and then we'll move on and look at how we can actually measure the strength of the relationship between the two variables when we're looking at a scatter plot and a line of best fit.